Hi everyone! Today we're building a control panel with switch and lights that simulates a spaceship interface. In this project, we'll learn about digital inputs and outputs, basic programming structure, and resistors. We will upload our first program using the Arduino IDE. So make sure that you have the Arduino IDE on your computer. You can use either the desktop version or the online web editor. If you're not sure what is an Arduino IDE, check our video for setting up the tools. Open your projects book to page 32 and collect all the materials needed for this project. Let's take a look at our Arduino Uno board. On this side you have the digital pins, and we're going to use those today. Digital signals can have only two states. They can be either on or off. However, the Arduino's digital pins can act as both inputs and outputs. An input is when the microcontroller receives information from any external component. This means that the data is flowing towards the microcontroller. An output is when the microcontroller sends information to the components. The data flows out from the microcontroller. For example, a switch is an input that can tell if it's pressed or not. And based on that information, we can turn on and off an LED, which is an output. After building our circuit, I will tell you how to configure and control inputs and outputs by writing sketches. First, check that your board is not connected to the computer. I start my circuit with connecting the three LEDs. The LED is polarized component, so we need to connect it the right way. The long leg goes to digital pin and short leg goes to ground. So I'm going to connect the long leg to the row 5 and short leg to row 6. Here. I will use a jumper wire and put it to the same row as the long leg. And use the digital pin 5. Then I'll take the resistor and connect the short leg and the other end of the resistor I will connect it here. I will have the ground here. Now we have all the LEDs connected and they go to digital pin 5, 4 and 3. It is important that you know which LED is connected to which pin. We will need that later in our sketch. Then I will add the switch. And the other leg is connected to power. I'm gonna later have the jumper wire for this rail, so I will have the power here. Good tip that if it feels like some component is not working, maybe the jumper wire is not connected properly, so it's good to press them. So then from the other leg I will have the resistor going to the ground, but I will also connect the same leg to digital pin number 2. And now I will connect the ground from here to this rail and power from here to this one. And make sure you have the resistors connected to the ground one, and then here the switch, the leg to power. Now that our circuit is ready, we can connect the board to the computer and open the Arduino IDE. Open your Arduino IDE. You can use the desktop version or the web editor. Open the example. You can find it from File, Examples, Built-in Examples, Starter Kit Basic Kit, and a spaceship interface. You can now upload the code to your board and see how the project works. When I press the button, the red LEDs blink. And when I don't press the button, the green LED is on. Open your book to page 36 to find explanations for the different parts of the code. In the example code on your IDE, you can see a lot more text compared to the code you have in the book. That is because we have added comments to the sketch. Comments are notes that help you and other people when reading the code. In the beginning of the code, we have a variable called switch state. You can see that in the book the S in the middle is a capital letter, and in the sketch on your computer it is not. Both are right because you can decide the name for the variables yourself. However, pay attention to the case sensitivity. You need to write the name the exact same way whenever you use it in the sketch. In Setup, we configure the digital pins. Here in the pin mode, you need to make sure you have the same pin numbers as you use with the physical components connected to the board. In Loop, we write most of our code. Function digital read is going to check the state of pin 2, is it high or low, and store the value in the variable named switch state. If the button is not pressed, the switch state variable will be low, making this statement true, and the part of the code between the curly brackets is executed. Note that when we compare two values, we need to have two equal signs. When the switch is pressed, the if statement is false, and the part of the code below else and inside the curly brackets is executed. Try adding one more green LED to your circuit and modify the example sketch. When the switch is not pressed, one of the green LEDs will blink. Before modifying the sketch, make a copy of the example sketch and save it using some informative name, for example, Project 2 Challenge. Today we were using two different kinds of resistors. Open your book at page 41 and let's take a look at all of the resistors we have in the kit. You'll find either a 4-band or 5-band type for every resistor, but you read the values of them similarly. The ones with the brown background are 4-band types, and the ones with blue background are 5-band types. First, you need to identify from which side you read it. Lay it down and look for the tolerance band. On the brown 4-band version, you usually identify the tolerance band from the gap between the other bands and the tolerance band. And on the blue 5-band version, the tolerance band is a bit thinner than the other bands. Place the tolerance band to the right. Now that you know from which side to read from, start from the left. Identify the color of the band and match it with its corresponding digits in the table from page 41. First one is red, so that means number 2. The second one is also red, and that means number 2. The third one is number 0 because it's black. And same for the fourth one. It's black, so it's number 0. Since the fourth band is a multiplier, it means that this is a 220 ohm resistor. Remember to use a resistor if it's required. Next time, you will learn how to